2, 1, mark.
And we're at T-minus 4 minutes and counting.
3 minutes, 55 seconds.
Atlas and Centaur stages will be transferred from ground facility power to internal battery. At T-minus 1 minute 55 seconds, the team will command the ground launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. T-minus 3 minutes and counting. A brief look at the Mission Director Center and the Atlas Spacecraft Operations Center.
50 seconds.
FTS internal.
And the Launch Control Center. Flight termination system is on internal. Everything is going by the timeline. Standing by to transfer the Atlas power to internal and the Centaur power to internal in about 25 seconds. Once again, crowds gathered expectantly awaiting today's launch, a little more than 2 minutes away. T-minus 2 minutes and counting.
1 minute 59.
Vehicle internal.
155.
Bot sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
Flight control system is to launch enable.
FTS armed.
In the final minute, the Atlas tanks will be verified at flight pressure, followed with verification of the Centaur tank pressures. 1 minute, 21 seconds and counting.
OCUs armed.
FCS count started.
115. 110.
Step out block.
T-minus 1 minute and counting.
Status.
Range green.
No issues with the range. Everything continues to be go. A final status check of Atlas, Centaur, and OSIRIS-REx readiness will be conducted 25 seconds away from launch. T-minus 40 seconds.
Stable at step 3.
28. 25.
Status check. Go Atlas.
Go Centaur.
Go OSIRIS-REx.
Everyone is go. Standing by for launch. After liftoff, you'll hear the voice of United Launch Alliance's Marty Malinowski providing launch vehicle ascent data. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Fireworks look good. Target pump speeds and injector pressures are within family. Beat chamber pressures have plateaued, begun to ramp off.
Heard the voice of Marty Malinowski. The Atlas has begun a pitch and yaw maneuver to steer to its planned path, 28.5 degrees inclination from the equator.
SRB chamber pressure is almost plateaued at this point. Already 180 injector pressures are good.
45 seconds into flight.
Whole program is complete. Boosters throttled down.
And the Atlas rocket carrying OSIRIS-REx has gone supersonic. Standing by to pass through max Q, maximum aerodynamic pressure.
Max Q, vehicle body rates continue to look good.
This is the point when the mechanical stress on the rocket reaches its peak
And
because
booster
of the
has
rocket's
throttled back up.
velocity and resistance created by the Earth's atmosphere.
Signatures look good. Current altitude is 14 miles. Downrange distance is 9 miles. Current velocity 2,488 miles per hour. Range track shows vehicle progressing down the middle of the range.
In about 30
180
seconds,
continues to look
the
good. Pump
single
speed.
solid rocket booster will be jettisoned at 2 minutes 19 seconds.
And booster has throttled back down. It's now 50% of its liftoff weight. Next major event will be SRB jettison, coming up momentarily. we
And
have
you see the
indication.
solid rocket booster jettison.
Separation looks good. Vehicle has enabled closed loop Q alpha steering.
RD-180 engine continues powering the Atlas, Centaur, and OSIRIS-REx into space. Next major milestone will be booster engine cutoff, 4 minutes and 2 seconds into flight.
Valve has been fired. That system is now pressurizing to flight level. Signatures look good. Current altitude 40 miles, downrange distance 75 miles, current velocity 5,988 miles per hour. Range track looks good.
About 1 minute away from Atlas booster engine cutoff.
Already went to burn well. Pump speeds, injector pressures within band. Vehicle body rates look good. Vehicle is now 1/4 of its liftoff weight. Coming up on our 5G throttle segment momentarily. And we have begun throttling to maintain 5Gs. Signatures look good. Boost phase cooldown is underway. And begun to throttle to 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good.
Booster engine cutoff confirmed. Standing by after
And we have
spacecraft separation for the Centaur single RL-10C engine to ignite.
We have ignition and full thrust on the RL-10. Coming up on payload frame jettison.
Everything continuing normally. The Centaur engine producing 22,900 pounds of thrust, and it will burn for just over 8 minutes.
Centaur body rates look very good. Steering has been enabled.
And the payload fairing, which was covering OSIRIS-REx, was jettisoned. Everything continuing on the timeline.
Current altitude for Centaur is 101 miles. Downrange distance is 471 miles. Current velocity 12,589 miles per hour. We do have a report from the booster performance, and it is basically nominal. Centaur PU is currently on the box bridge stop. Chamber pressures look good. Box pump discharge, fuel venturi, and pump speeds all are good.
6 minutes into the flight of OSIRIS-REx.
RL-10 continues to perform well. Chamber pressures, LOX pump discharge, and fuel venturi all within expected range. Centaur PU has come off the LOX rig stop. Body rates controlling down the middle.
About 6 minutes left in the
Ready.
burn of the Centaur engine.
Battery voltages all are stable at this point. Tank pressures look good. And we have had the format change. Very minor loss of data during that. We're seeing our normal thermal conditioning firings on the RCS. Line temperatures have nearly warmed to bottle temperatures at this point.
Once again, you're
Coming
hearing
up
the
on
voice of
Centaur
United
range.
Launch Alliance Marty Malinowski
Range track.
calling the ascent of the vehicle.
We're still making good progress down the middle of the range. And Centaur has begun RAN steering at this point. Current altitude 139 miles, downrange distance 1,008 miles, current velocity 13,783 miles per hour. And the RL-10 continues to perform well. Chamber pressures, LOX pump discharge, and venturi all where we would expect for the SET-MR. Centaur body rate still controlling down the middle.
About 4 minutes remaining in the burn of the Centaur engine. You can see the
Centaur
spacecraft
currently is flying at an
traversing
altitude
out over the Atlantic
4
Ocean.
miles, downrange distance 1,275 miles, current
On a
velocity
28.5 degree inclination from the
14,454 miles
equator.
per hour. Range track again continues to show good progress downrange. Centaur PU has worked off most of the oxidizer air at this point, controlling near nominal. Chamber pressures, LOX pump discharge, and fuel venturi again all as expected for the SET-MR. Body rates are good. Centaur continues to perform well. Current altitude 145 miles. Downrange distance 1,597 miles. Current velocity 15,333 miles per hour.
Just a little over 10 minutes since launch, and everything continues to go well.
Approximately 2 minutes remain in this first burn. All Centaur systems look good. phenomenal. RL-10 performance continues to look excellent. Body rates controlling down the middle. Approximately 1 minute remains in this first burn.
Standing by for the second stage Centaur engine cutoff.
138 miles, downrange distance 2,143 miles, current velocity 16,942 miles per hour.
MECO 1 coming up in about 10 seconds.
Vanish. And we have IAP vanish. Centaur is now orbital. And we have MECO. Engine shutdown looks good.
MECO is
We have
confirmed.
safety flight termination system. Centaur has gone to 4S settling.
Another Centaur burn will follow after about a 22.5-minute coast period. That burn is scheduled for 33 minutes, 48 seconds mission elapsed time, or about 7:38 p.m. Eastern Time. As the journey continues to
This coast phase is scheduled
put
for
OSIRIS-REx into its planned location in space.
Followed by a second burn of 407 seconds and a final coast to spacecraft separation of 15 minutes. Centaur tank pressures, storage bottles, batteries are all stable.
The Centaur engine will burn once again before finally releasing the OSIRIS-REx spacecraft into space about 55 minutes and 38 seconds after launch.
And looking at the MECO 1 plus 3 second open shows Centaur's right where we expected, and comparing the pre-flight to the actual position of the vehicle. Centaur RCS has begun to ramp to a 25% 4S duty cycle.
Once again, we're in a coast phase between burns of the Centaur engine. We're expecting that the next burn will begin in about 16 minutes. And right now, while we are awaiting the engine restart, we'd like to show you an interview that NASA Communications Representative Josh Finch conducted with NASA Chief Scientist Ellen Stofan.
Thank you. I'm here with Dr. Ellen Stofan, NASA's chief scientist. We're just outside of the Vehicle Assembly Building, and just a few miles away is OSIRIS-REx on the launch pad, ready to head to the asteroid Bennu to collect a sample and then return it back to Earth. Dr. Stofan, what can we learn about studying asteroids that could benefit us in learning about our solar system?
Asteroids are the primitive material left over from when the planets formed. So the Earth, us, this building, everything around us. Asteroids are the key to what were those materials that everything that is around us was made. Now everything on the Earth has been processed, all this material has been processed and processed. Asteroids are the pristine material, and we know they contain really interesting things like the water, that is the water that originated our oceans and all the water here on Earth, and they actually also contain organic molecules that help make us.
And so why did NASA pick Bennu as an asteroid to study, and what are the benefits of a sample return mission?
You know, Bennu is what we call a carbonaceous asteroid. Now, carbonaceous asteroids are the ones where we know they have a lot of water in them, and again, we think that water is the source of the water that's here on Earth, and we know they have organic molecules on them. In fact, some of the letters in our DNA that make up our DNA, those molecules have actually been found in carbonaceous meteorites. So Bennu could hold keys not just to the origin of water on Earth, but to the origin of life on Earth. So we're particularly interested in that type of asteroid. Now, when you send a spacecraft to either a planet or an asteroid, you take along instruments and you do the best job you can of characterizing the material. But you have to realize when we shrink a scientific instrument to fit down onto a spacecraft, it becomes a little less capable. If we can actually bring those rocks back here to Earth, we can analyze them with instruments that fill a room, basically. We get much more precise and better information. So scientists, especially geologists like me, we like to get those rocks back here on Earth where we can do really amazing science with them that we just can't do remotely.
And now NASA's planning to do an asteroid redirect mission and then eventually a journey to Mars. How does this mission help that goal?
You know, because small bodies are potentially really interesting in the future for resources, they're really interesting for water, and of course we're concerned about them from a planetary hazard point of view. Asteroids have hit this planet in the past, and they will hit us again at some point in the future. The asteroid redirect mission tests technologies like solar electric propulsion that we're going to use to get cargo out to astronauts who will someday be out at Mars. We're also going to be testing techniques that will help us understand how we might in the future potentially deflect a hazardous asteroid. So it's helping us protect this planet, and the asteroid redirect mission is going to help us to get us on our way to getting humans to Mars. And OSIRIS-REx is really the first step. It's teaching us how do we get to a small body, how do we maneuver around it, how do we get a sample back. It's the first step. The asteroid redirect mission is the next step.
Excellent. Well, thank you for being with us today. And back to you.
Thank you, Josh. Everything continues to go well. Once again, looking at animated graphics driven by real-time telemetry showing the position and status of the Centaur spacecraft with the OSIRIS-REx payload. The next burn of the Centaur engine scheduled for 33 minutes and 48 seconds after launch. So about 12 minutes from now. Once again, everything continues to go well. Heading toward an on-time deploy of the OSIRIS-REx spacecraft about 55 minutes and 38 seconds following launch. This is Atlas Launch Control.